calculator, that works for you. Just make sure you change your scale because you can't see it in your table. All right, so some of these just had basic shifts. The first one had a vertical shift down 1. Everybody okay with that? How about this one? This had an amplitude change of 3. Everybody good with that? Okay, stop me if you're not good. This one had 2 things. Amplitude change, vertical shift. Did everybody get these points? So you're going to start with your cosine curve. 1, 0, -1, 0, 1. Don't even start to graph yet. Multiply everything by a half. Then take this and add 1 to everybody. Add 1. So this gives you 3 halves. 1, 1 half, 1, 3 halves. Graph those points. 3 halves. 1, 1 half, 1, 3 halves. See it? No less.
The way that they write the frequency is wrong, right?
The way that their frequency, yeah. I don't know why they do it that way.
It would just be like,
The frequency is the number in front of this guy, which happens to be a 1. So they're saying there's 1 frequency. The way they say it is 1 frequency in 2 pi. 1 complete curve in 2 pi. So that's where we do our period says 2 pi because it's 2 pi over b. Their frequency b is 1, which just they say as a cycle. So instead of saying b equals 1, they say there is 1 cycle in 2 pi. This is another way to say it. Amplitude 1, midline, everybody comes up 1. This is the effect right here. So from here was your midline, it jumps up to here. So you can see your midline, resting line, midline, whatever you want to call it. Okay. This guy says do half of my curve. Do half of my curve in 2 pi. So it does half of your curve. Here's the sine curve is the nicest because half of your curve is that first hump. The other half of your curve, the bottom hump. And think of it logically. Yes?
would the frequency be what?
The frequency just says there's one full curve in 4 pi.
I know.
So the B, this is B. Yes, this is your frequency, meaning you have a half a curve in 2 pi. They just write it in terms of a full cycle. So what they say is it takes you 4 pi to complete a curve. So they write their frequency as 1 cycle in 4 pi. But we technically say half a curve in 2 pi. They just have another way to say it. Everybody says it a little bit differently. I like to say it this way because we work off of a 2 pi window usually. So we say there's a half a curve in 2 pi, so you visualize it. Then your period says, oh, full curve, 4 pi. There's a couple of different ways you can say it. They just say it differently. Cosine, you need to fit 2 cosines in 2 pi. So every pi is a cosine curve. You were okay with that? Those are nice ones because then when you separate your pi to 2 pi, you're working on a quadrant of 45 degrees because you separated your 90s in half. Those work really nicely. I'm going to leave 6 for a second and come back to it. This one, we didn't talk about the negative yesterday. I wanted to and we didn't get to it. The negative is your reflection. However, when you work with the sign, 0, 1, 0, -1, 0, multiply everything by the -2. This flips it over. So these are the points that you want to start with. See how they go 0, -2, 0, 2, 0, -2, 0. It keeps going like that. Now, this tells you 2 curves in 2 pi. So your period is going to be pi. So I want to separate this. I want to make my tick marks here. And I want to follow this. This forces the reflection. That negative, your amplitude, what is the amplitude for this guy? 2. Good. Your amplitude is always positive because it's a distance from here to here. That negative does the reflection. But when you take your points out there, multiply it by the negative. That forces your reflection. Okay, we're going to come back to the phase shift. I just want to get through the others. Okay, this guy, you had to put 3 curves into pi, and you had to vertically shift it up 1. So I would start with my 1, 0, negative 1, 0, 1, and add 1 to everybody. 2, 1, 0, 1, 2. These are the points you're graphing. How often you graph them is what the frequency determines. So I need 3 of them, so every 120 degrees. And yesterday we did one with 3, and we said if it's 120 for one cycle, 4 quadrants puts me every 30 degrees. So it's easier to take this and separate this into 30s. Because it's nice your quadrants are every 90. So you can fit 3 30s into that 90. 2 tick marks and do 3 30s. And then follow that pattern. You okay with that? Lane, are you okay with that?
Yeah, I forgot to bump them up.
To bump it up 1. Okay. Because sometimes they have more than one thing going on. I'm going to skip that day shift for a minute and come down to here. This one had a couple of things going on. This one is a good one. What does this 2 mean? Amplitude 2. So right away, I'm 0, 2, 0, negative 2, 0. What does this guy mean, the negative 1? Shift down. So I'm going to subtract 1 from everybody. Negative 1, 1, negative 1, negative 3, negative 1. Is that right? Okay. Then what does this 2 mean? 2 cycles in 2 pi. So now I'm going to deal with my 2 cycles in 2 pi. I'm going to cut it here, and I'm going to say, oh, life is easy. Every 45, and I start. Negative 1, 1. Where am I? Negative 1. Oh, negative 3, 1. I'm off a little bit. Negative 1, 1, negative 1, negative 3, negative 1. There's my first cycle. Then I do it again. And you get 2 loops, 2 complete cycles in 2 pi. That one had a lot of good things in there. Can everybody do that? If you put it in your calculator, that works in your calculator very nicely. The only thing you have to worry about is changing your table set. Take your frequency, find your period, do it in degrees. Since you're going to graph in degrees, 360 divided by 2 is 180. You need 4 quadrants. So your table, your change of table, should start at 0 and should go every 45 degrees. If you don't change your table set, you get the graph, but you're going to get like weird numbers and sometimes all zeros or all ones or something different, and you can't graph it. So make sure your table set goes to your quadrants. Questions? All right, let's take one of these spaceships out here. Take a nice simple one. 6. God bless you. Okay, good. 6. All right. So when we did this, what did this do? Horizontal shift to the right. We technically have the same thing, but we just have to call it a little bit different. Because we're shifting not in numbers, we're shifting in angles. We call it a phase shift. And a phase shift is, it's a little bit different. Right now this is a 1 out here, so we're okay with this. But generally it would be C over B. We consider, I'm going to have to expand this a little bit. This is A cosine BX plus, this should be really plus D, but right in here, this is where my C goes, in here somewhere. So we have to say C over B. Now, I don't put the sign in there, the positive or negative. I do this first. I say this is going to go to the right. Pi over 1 units. So so that you keep the same kind of transformation that you always did. Inside the parentheses, it goes the opposite way. So all this is saying is before you do your cosine curve of 1, 0, negative 1, 0, 1, I want you to start someplace else. I want you to take the 0 and I want you to go to the right, pi units. I want you to start it right here, pi units. 1, 0, negative 1, 0, 1. So there's where my curve is technically going to start. Does this curve really have a beginning and an end? No, because it's continuous. So when I go backwards, don't I go here? But my curve technically said shift from here to here before you start. So that we keep this continuous, we have an easier way to do this. We say, okay, one full cycle normally goes from 0 to pi, right? So you just take what's ever in here and you set this equal to 0. Then you take what's ever in here and you set it equal to 2 pi. Because technically I should go from 0 to 2 pi, right? So if I want to know where is my first full complete cycle, even though it's a continuous curve, I want to know where my cycle is, I just set that little argument to 0. So my angle goes from pi, I add the 2 pi, to 3 pi. Isn't that a 2 pi cycle? Because nothing else changed. I didn't change the frequency yet. Okay. Nothing else changes in here. So technically, if I'm here, wouldn't this go out to 3 pi? 2 pi, then 2.5, and then I'm on to 3, right? But because this is a continuous curve, we're not just going to start it right here and leave it sitting here, right? We're just going to go backwards with this to continue it. Technically, my first full cycle, if I'm looking at a full cycle, instead of from 0 to 2 pi, because that's my window, I'm shifting it and going from pi to 3 pi. Does that make sense? Okay. Now we'll do more of these, guys. Let's do this one down here, because this is just the opposite. What just happened? Sorry about that. I don't know how I changed the screen here.
Wait, so I don't really get that at all.
You didn't get that at all? Okay, let's try another one. Let's try this. So if I did this, I'm trying to keep your transformations to look the same. When we had it inside here, we went horizontally the opposite way, right? So if this is a plus now, what way am I going to go? To the left. I'm going to start this to the left. It's going to shift, and that's a 1 again. C over B, so pi over 1. It's going to shift pi units to the left. Horizontal shift. This would be how I describe my transformation. Pi units to the left. Agree? So I should start the cycle at negative pi. I should come out here to negative pi and start my cycle. My cycle of sine says 1, 0, 1, 0, negative 1, 0. Now, I'm going to go start this at negative pi. They don't have a negative pi out here, so I'm just going to extend this right now. There's 0. There's negative pi over 2. Here's negative pi. Kind of hang in there with me for a second. So I'm 0. I'm 1. I'm 0. I'm negative 1. I'm 0. There's my first cycle. This is continuous, right? So I do it again. I'm 0. I'm 1. I'm 0. I'm negative 1. I'm 0. I don't know why they didn't extend it to do the negative side on this. So I really didn't like these phase shifts, but we'll do some more together. But do you see the concept? This is a continuous curve, so it seems like it's silly to say, where do I start and where do I stop this? But when you're looking at a window from 0 to 2 pi, we generally look from 0 to 2 pi to say, that's one cycle, because we say, your period is 2 pi over b. So in the course of 2 pi, how many cycles do you fit there? So we work off of this and we say, okay, then set this to 0, and set this to 2 pi. Because technically, I work my curves from 0 to 2 pi. So I subtract, and my first full cycle is going to go from negative pi to positive pi. Make sense? All right, let's do one together. Let's take this